what will be the next rule? Asymptotes. What do you mean by asymptote? Asymptote is an imaginary straight line which will guide one of the root locus to reach infinity. Starting point is always open loop pole, ending point, so you may not have those many number of zeros. So those root locus branches, they have to go to infinity, and everywhere in 360 degrees we have infinity. Therefore, to guide the root locus branch, we have asymptote. So asymptote is an imaginary straight line which will guide one of the root locus branches to reach infinity. Now, how many such asymptotes needed? Now, we know it's very clear, if poles and zeros, open loop poles and open loop zeros are not equal, then we need to have asymptotes. So I can write asymptotes A is equal to P minus Z, and you can write the mod of it. So in a control system, in a real-time control system, number of poles and number of zeros are equal, or number of poles greater than number of zeros. That means your transfer function may be either proper or strictly proper. It cannot be improper. So all the time your A is equal to P minus Z only. So number of open loop poles minus number of open loop zeros. So that will be the asymptote. Now, so what will be the starting point of the asymptote? So all the starting points will start on the real axis. So if this is the S plane, in this S plane we have real axis from the origin to here a negative real axis, from origin to the other side is a positive real axis. On this real axis we will have a starting point of the all the asymptotes. So the starting point of asymptotes or meeting point of asymptote is called centroid. Then how to find the centroid? So centroid is equal to, we have formula, sigma poles minus sigma zeros divided by P minus Z, again it is mod. So what do you mean by sigma poles? You know the location of the open loop poles. What are the sigma zeros? You know the location of open loop zeros. You just substitute it so that you will get the centroid. For example, if you take open loop transfer function like gh of s is equal to k into s plus 1 divided by s into s plus 2 into s plus 3, right? Gh of s, k is open loop gain, which is a variable parameter, s plus 1 divided by s into s plus 2 into s plus 3. So locate poles and zeros. So once you locate poles and zeros, this is my S plane. So we have like this. I have initially one infinite zero, polate infinite pole, polate origin. I can locate the polate origin. This is polate origin. Then we have s plus 1 in numerator, which is 0. So s is equal to minus 1. You will have 1 0 here. Then after that I have one pole and I have another pole, s is equal to minus 2 and s is equal to minus 3. So you know the pole locations and zero location, how to find the centroid. So centroid is equal to sigma poles, means 0, minus 2, again minus 3, and whole minus of minus 1 divided by P minus Z. I have 3 poles and 1 0, 3 minus 1 is 2. So this results in a centroid of minus 2. So minus 2 is a centroid where all your asymptotes will start. Okay. Then when the starting point we know, at what angle they go to infinity. So the angle at which asymptotes will take up from the centroid is called angle of asymptotes. So number of angles depends on number of asymptotes. If you have only one asymptote, there will be only one angle, and if you have two, again two angles. So we have formula to find the angle of asymptotes, that is theta is equal to plus or minus 180 into 2q plus 1, where q varies from 0, 1, 2, 3, 4 and so on, divided by P minus Z. So depending upon your P minus Z, then you will have angle of asymptotes. For example, if P minus Z is 1, so P minus Z is 1 in the sense you will have only one asymptote. So the angle I can take it as directly, it is minus 180 degrees if at all, if you substitute it. So there if we need to substitute q from 0, 1, 2, 3, 4. So 0 we need to substitute if P minus Z is 1. That means if you want one value, q is 0. If you want two values, then q must be 1. So that way we need to substitute q. Q starts from 0, 1, 2, 3, 4. So what will be your asymptotic angle when P minus Z is 1, that means the difference between the number of open loop poles and open loop zeros is 1, it is minus 180 degrees, straightforward you can remember. So theta 1 is minus 180 degrees. So when there are two poles, when there are two asymptotes, P minus Z is 2, the angles directly I can write it as theta 1 is plus 90 and theta 2 is minus 90. Or you can take all minus values, minus 90 and minus 270. So what is this minus and plus? So we have this S-plane, then we will take the right side, means the positive infinity line. That line usually we take it as a 0 degrees. And from that 0 degrees, if you take the angle in counterclockwise direction, then you should take negative. If you take the angle clockwise direction, then that will be positive. Right. So when I take the 180 degrees, when you take clockwise direction or anti-clockwise direction, you are going to reach the same point. So plus 180 minus 180 will be same. So similarly plus 90, so plus 90 minus 90 two different, but minus 90 minus 70 two different, but plus 90 minus 270 will be same. Because when you measure angle 90 degrees like this and you measure angle 270 degrees like this, both will be same only. Therefore, we can take all minus. So when theta 2, that means when two asymptotes are there, two angles will be minus 90, minus 270, or else we can take the angles are plus 90 and minus 90. So similarly, if your P minus Z is 3, that means number of asymptotes is 3. So number of asymptotes 3, then we can directly write your theta 1 is nothing but minus 60 degrees, then theta 2 is nothing but minus 180 degrees, and theta 3 is nothing but minus 300 degrees. So likewise, you can calculate angle of asymptotes and we can calculate centroid. So we can sketch those things. So this information is useful for us to construct the root locus. Next, so your next rule says that what is the root locus area on real axis or otherwise. So when we say a point on the root locus, when we say the point on the real axis is a part of the root locus, or that point will lie in the root locus. Then we have the definition of this rule. So this rule says that a point on the root locus lies on the real axis if from that point to right side, if your number of poles and zeros is odd number. So if it is even number, so that point is not part of the root locus, so it does not lie on the root locus. So real axis, you can take the real axis, on this axis you can take any point, and from this point to right side you should count how many poles and how many zeros are there. If the total count is odd number, then the point will be there on the root locus. If it is even number, then that point won't be there on the root locus. That means that point cannot be taken as a root locus area. So this is very important because when you calculate breakpoints, where is a breakaway point or break-in point, so you will have valid breakpoints and invalid breakpoints. So to know the valid breakpoint should be there on the root locus area. That means you can divide this entire real axis into different segments, and each segment you can say whether that is a part of real axis or not. So for example, if you take the same problem, I have open loop transfer function gh of s is equal to k into s plus 1 divided by s into s plus 2 into s plus 3. So we know already how to locate poles and zeros. So I am going to locate here, this is origin in this S plane, this is origin, and after that at origin I have pole, and after that I have a 0 at minus 1, then after that I have at minus 2 I have one more pole, minus 3 another pole. So therefore the entire real axis I can divide into different segments. For example, in this case the rightmost is plus infinity. So plus infinity to origin is, let us say, one segment, and origin to, because at origin I have one pole, and origin to the next polar 0 is one segment. That means from 0 to minus 1 is one segment, and minus 1 to minus 2 is another segment, and minus 2 to minus 3 is another segment, and minus 3 to minus infinity is another segment. So this complete I can divide into these many segments, and if you want to know that particular segment, in that particular segment whether you have the root locus or not. So let us take the first segment from plus infinity to 0. If you take any point in this segment, from that point to right side, if you measure number of poles on zeros, there are no poles on zeros. That means from origin to plus infinity, we don't have any root locus on the real axis. Let us take the second segment from 0 to minus 1. Take any point in between, count number of poles on zeros right side. So there is a one pole at origin, the number is odd number, which means root locus can exist between 0 and minus 1. Similarly, from minus 1 to minus 2, take any point, count poles on zeros. You have to count the number of poles on zeros. So in between minus 1 and minus 1 and minus 2, if you take any point, if you count, that gives me even number, because I have one pole and one zero, total will be even number. Therefore I can say, so between minus 1 and minus 2, you don't have any root locus area. If any point lies in that, I can say that point is not part of the root locus. Similarly, from minus 2 to minus 3, yes, if you count, the number is 3, odd number. So there exists from minus 2 to minus 3 root locus area. Then again the last segment, minus 3 to minus infinity. So here if we count, so the number is 4, therefore from minus 3 to minus 3, we don't have any root locus area. So this complete real axis, now root locus can exist only in between 0 and minus 1, minus 2 and minus 3. So remaining area we don't have any root locus. So if you want to know any point in the complex plane, whether the point is there on the root locus or not, we already discussed that you can use the angle criteria or magnitude criteria. So using that you can say that particular point is the part of the root locus or not.